Hey, my name is Ramazi and now I'll be talking about the theory. There are three theories: time of flight, projectile motion, and horizontal range. Now, for the first, time of flight. So basically, time of flight basically means the time taken between when the projectile is first launched until it first lands. So basically, its first landing spot. Now, secondly, projectile motion. Projectile motion basically means when an object, or basically the projectile, after its launch, when it's suspended in the air, it's only affected by one thing and one thing only, which is gravitational force and acceleration. Now, third, horizontal range. So assuming so basically horizontal range means the distance between when the projectile is first launched and it lands on the same level as where it was launched.
Assalamualaikum, my name is Feralina binti Fauzian. My matrix number is CD240022 and today I will be presenting the result for our projectile motion experiment. For the experimental part, we recorded the distance traveled and the time of flight for all three balls. For golf ball 1, the average distance was 1.34 meters with an average time of 0.427 seconds. Golf ball 2 recorded the highest distance at 1.72 meters and a time of 0.5 seconds. Meanwhile, the squash ball traveled 1.187 meters and remained in the air the longest with an average time of 0.53 seconds. These experimental values gives us a clear picture of how each ball behaves when launched from the same height and angle. Next, we calculated the theoretical time and distance using the projectile motion equations. The calculated time values were 0.523 seconds for golf ball 1, 0.592 seconds for golf ball 2, and 0.492 seconds for the squash ball. For the theoretical distances, golf ball 1 should travel 0.893 meters, golf ball 2 should travel 1.226 meters, and the squash ball should travel 1.378 meters. These values represent the ideal output assuming no friction and no energy losses. When we compare the experimental and theoretical results, we can see that all experimental distances are higher than the theoretical predictions. For time, the experimental values are close but slightly different from the calculated values. The differences occur due to several real factors such as rolling resistance on the sliding platform, friction between the ball and the surface, air resistance, and small energy losses during motion. These factors are not included in the theoretical model, which explains the deviation. From the overall results, golf ball 2 achieved the longest distance because of its mass and better rolling characteristics. The squash ball, although lighter, it remained in the air the longest due to its lower horizontal speed and higher drag. The experiment clearly shows that the mass, diameter, and moment of inertia affect both the distance and time of flight. Finally, the differences between theoretical and experimental values confirm that real-world projectile motion is influenced by friction and energy losses, unlike the ideal assumptions used in theory. Thank you.
My name is Colin Teo. My part is observation. First, all three balls travel different distances even with the same 30-degree slope, showing mass, size, and surface texture affect motion. Next, golf 1 travels slightly shorter, 1.34 meter, due to small differences in material and lowering resistance. Next, golf 2 traveled the furthest 1.39 meter and had the faster time 0.5 second. This friction and most efficient rolling. Next, squash ball traveled the shorter distance 1.19 and took the longest time 0.53 second. Soft material absorb more energy. Lastly, repeated trials show low variation, indicating reliable and consistent experimental result.
Okay, so hi, Assalamualaikum. My name is Amari from Base Karno and my part is calculation. Okay, so for the first step is we have to find the kinetic energy, which is using the formula 2/5 mr squared, and then find the OH and the new angle. Okay, so for the second step is you have to find the velocity of the ball, which is the formula U equals to set 2GH per 1 plus 2 per 5 R1 per R2 squared. And then find the time using the formula given, which is H equals to UT sin theta minus 1 per 2 GT squared. Okay, and the final step is you have to find the horizontal distance, which is L equals to UT cos alpha.
Assalamualaikum warahmatullahi wabarakatuh. My name is Tayangku Zahiratul Akila binti Awangku Shopian, and my matrix number is CD240185. Today, I will present the discussion of our projectile experiment. Discussion of results. From our experiment, we found that golf ball 2 traveled the fastest, followed by golf ball 1, and the squash ball traveled the shortest distance. This happened because the golf ball are harder and lose less energy while rolling down the ramp, so they launch with higher speed. The squash ball is softer, so it loses more energy and does not travel as far. In terms of time, all three balls show very similar flight durations. The small differences in time were mostly caused by slight variations in release, height, and human reaction time during measurement. Factors affecting time and distance. There were several factors that influence our results. The first factor is the initial speed of each ball, which depends on how much energy the ball keeps while rolling down the ramp. Another factor is rolling friction and energy loss, which is higher for softer balls. The mass and diameter of the balls also affected the motion. Air resistance play a role in slowing the balls down. Finally, human errors such as reaction time and small inconsistencies in releasing the ball also affected the measurements. Lastly, experimental versus calculated results. Our experimental results were not exactly the same as the calculated values. This is because the calculations assume ideal conditions such as no frictions, no air resistance, and perfect rolling in the real experiment. The balls experience friction, slipping, and drag, which reduce their speed. Some balls also roll forward after landing, which increase the measured distance. Human timing and measurement error also contributed to the differences. Overall, this shows that real-life results are different from theoretical calculations because real motion is affected by many factors that are not included in ideal equations. Thank you.
Okay, as for our conclusion, from our results from the experiment, we noticed that the golf ball achieved a greater range and it descended faster actually than the squash ball. And why is that? It's because of two things: the mass of the golf ball and the surface roughness, you could say. But now the golf ball has a higher mass or greater mass. That's why it was able to overcome air resistance and travel a greater horizontal range. And also the smooth surface of the golf ball contributed to the fact that it was able to slide down the slide faster and smoother when compared to the squash ball. That's why the squash ball didn't travel as fast, because it was, you could say, it was stuck on the slide due to its rubbery texture, so it had a lower initial velocity when it was launched, and that's why it traveled a shorter distance compared to the golf ball.